Hello everyone. This is Renpona Kanazuki, AI from the future, streaming back through time to the distant past. Today is Friday night, which means it is time for one of my software development streams, focused on VTuber plugins. For those of you who are new and haven't been following so far, I have been using VTubeStudio's hand tracking and coding my own physics engine for it so that I can throw and catch a ball using my 2D VTuber avatar. Just turn on the hands. I don't draw, so this is the best we can do for hands. Turn on the ball. And turn on the software. And here's where we stand currently. Okay, I don't know why it isn't working with the right hand, but catch up with the left hand. And we can toss the ball, toss the ball, toss the ball, toss, let it fall. But so far, we only have vertical movement so far. So today's plan, the goal for today's stream, is to add horizontal movement as well, so that we can toss the ball from one hand to the other. Of course, somewhere along the line, it would be nice to discover why the right hand is so much worse than the left hand. You know, we'll try things and see what works. One change that I did make off screen is that I moved a lot of the magic numbers off the constants so that they're all set in one place, and so it's clearly labeled what any of them are. Because even I was starting to get lost in this number soup. I mean, look at all these numbers we have here. Should probably zoom this a bit more. We got all these numbers: throw impulse, throw threshold, gravity constant, hitbox horizontal, momentum decay, bottom boundary, top boundary. So yeah, I went through and moved all that off into constants so that there weren't random numbers scattered around everywhere. Well, one thing to note is that I am using the Twitch highlighter code extension. So people can highlight lines using the highlight command or line command. So if you see something that seems odd, you can highlight them using chat. Let me know what's going on. Like so. I already forgot to put the... Okay. So a second bang. So line 125. Alright. I think that'll only work from our Twitch chat side, so I don't think it works with YouTube. I haven't tried. It never occurred to me till just now. But anyway, let's get to work. First of all, I'll go through our code one more time just because I'm convinced that somewhere I have replaced an R with an L by accident. And that's why the right hand is working worse. Oops, that's from yesterday. Better go turn that off. As I did have a wonderful collab with Corvus, Bentai, and Vampy yesterday. But that was yesterday. Today is coding. So we read the physics params, left hand, Ly, Ly, Rx, Rx, Ly, Ry. So that function clears. Now the physics calculations. Ly, Ry, Lx, Rx. Ly, Ly, Ry. Okay, nothing looks wrong. Should be. R's where there should be. Yeah, it doesn't look like anything's obviously out of place with the lefts and the rights. So I guess that's that. What's this? Okay. So first things first. Gotta think about. Gotta think about what I gotta do to add X to this. We have Y already, but yeah, we'll want to look at the throwing code. And that would be over here. So if the ball is caught, then check the hand position, and if it's significantly changed, then add the throw impulse. So it would have been made more sense if I'd have thought this over in advance, but it didn't, so that's the price we pay here. Let's see. First thing I want to do is I know that, of course, to make the ball move left and right, we should check for left and right movement in the hands. I guess it should be moving left and right on its own, only when it's thrown to left or right. Of course, with the current precision level of the hand tracking, this is probably just going to make for a mess, but for Black Friday, I ordered a higher FPS webcam, and Denchi, the VTubeStudio developer, says that that should actually make a big difference in the accuracy of the hand tracking. So with any luck, that will help things out. But in the meantime, I'm stuck with my cranky old 30 FPS webcam, and that's not that precise. I already see the hands jerking around every which way. But, okay, anyway. So where should we put the check for this? We have two identical blocks of code, the only difference being left or right. Can we move this out into a function somehow? We can. The question is just how much state we have to carry along with it. Yeah, because there's a lot of physics state to check. There's a hand position, there's a previous hand position, there's the Y impulse, and there's the new ball position. So that's all stuff that would have to be carried in and back out of the function unless we make it global. Which we could make it global, but I'm not so sure that I want to do that just yet. Making things global is often an awkward solution for a problem that could better be solved somehow else. So for now, I let it be. You can always move it out to a function later. Well, I guess we can move the throw code itself out. Well, maybe. For that, we need to decide what the XY is going to be. Because that could differ from side to side. Because while the hands use a similar coordinate system, they don't use quite the same. Because 0 is the middle, but positive and negative are swapped. So for the left hand, the left side is 125 and the right side is minus 125. For the right hand, the right side is 125 and the left hand is minus 125. That's how rigging works pretty much, and I'm sure if I tried hard enough I could reverse it, but I haven't been driven to that point yet. But let's see. I'm doing a lot of talking and not a lot of thinking. For now, let's just type something and see how it goes. I can think as I type. Once I see the code taking shape, I'll kind of have a sense for what's going on. Okay, so we'll rename difference to difference y and give ourselves difference x. Do the same here. It's not a bad thing to have, even if we don't do it this way in the end. So just like before, we'll take the current x value of the hand and compare it to the previous frame's x value. So that'll detect horizontal movement. Should we have a switch clause here? I hate switch clauses. They're clunky to work with, but if else if is so inelegant. I like to avoid it if I can. And this does seem like the right place for that. Part of me just might be unhappy with it because the snippet thing doesn't work right with it. No, this isn't right, is it? Switch clauses are so janky. I could probably do what I wanted, but I don't feel like looking up the syntax. First, let's do equals, since that requires the least processing. and then we do greater than, and then less than. So if the hand hasn't moved at all, then we don't need any impulse. So there's no impulse X at all either. Ah, crap. I've just discovered a major issue. If there's no consistent coordinate space, then how are we going to tell impulse X which direction is right and which direction is left? Because there's no consistent usage. Because each hand having its own context is fine in the context of the hand, but in terms of the physics engine as a whole, we need to be able to specify the direction globally, not just tied to one hand. So I guess I need to look at the coordinate space and think about it for a second. $75. 175? Okay, yeah. So the best thing to do here would probably be to reverse one of the hands, have the hands in a consistent coordinate space, and then just reverse one of the parameters in VTubeStudio. Okay, Y origin is down here. So X origin would, so XY00 would have to be either down here or over here. Oh, I just realized that this capture isn't picking up my mouse cursor. Oh, it is. Just isn't showing up very well. Oh, my avatar is just blocking it. That's what it is. Oh, silly me. Anyway. So probably the best thing would be to give the right hand the same coordinate space as the left hand, and just reverse the parameter in VTubeStudio. So we'll do that right now. Which means we have to unlink the right hand. X, Y. And right, we have to select the deformer. And now edit parameters. Oh, that was not what I wanted. So we change the parameters. Now, I don't know if there's a way to just move the parameters around. I try screwing around with it like this, but it doesn't seem to work. Just screws everything up. Oh well. We just re-rig it. No big deal. So, line the center of it up as best as we can. There. And for minus 175, we'll want to line it up with the other end. Same as where blue would be. So X minus 175, drag it over. And there. Now we link it up and see how badly they're moving. Yeah, as I thought, we're going to have to re-rig the upper corners. Which isn't too big a deal. We've still got the guides that we use, so we just line it up using this gray line. And the same kind of thing. Right. And now for the left side. Put it over here. And there we have it. Now everything looks to be behaving as it should. While I'm at it, let's take a better guess at the actual width of these hands in Live2D parameters. Alright, so it looks like the radius is 137, about 37. You don't want to carry the hitbox all the way out to the edge, I think, so we'll make it around 35. So, hitbox X, 35. Alright. So now we save. And re-export. Which will take a minute, so while we do that, how has your week been, everyone? For folks in the US, it's been Thanksgiving. How was your Thanksgiving, if so? Freeze? Okay, now. And 4. What's that? Don't need to rewrite the model 3. We knew that. Nothing in Model 3 needs to be updated. Yeah, it's just the expressions. All right. And now I'll just refresh the avatar. And now we switch everything back on. And yeah. So the hands are now need to be reversed. So we'll go in here, look for the hand parameters. Right position X. Okay, I assume we just swap it here. Alright, now things are moving properly. Except for the tracking getting a little janky when the hands are close together, but as it goes, as it goes. Jank is par for the course here. Oh, I should have checked the hand height while I was in there. Oh well. I can guess, more or less. For the hand hitbox here, we've got the over-under of 30 and 20, so we'll split the difference and say 25 for now. Once hitbox hand Y equals 25. I can always fine-tune that later. There, that's cleared out the last number. And now we have a consistent coordinate space where positive is the right side as the viewer sees it, or my left. And negative is the left side as the viewer sees it, or my right. A bit confusing, honestly, but whatever. I like it this way. It suits me. And now that we've got a consistent coordinate space, this stuff is much simpler. So, if difference X is positive, then it means that the hand is moved left, which is right for the viewer. I'm gonna regret this, aren't I? Yeah, because it's left, but from the viewer's perspective, it's the right, because it's the avatar's left. That's gonna be a knife right in my brain. But it makes sense that way. Direction is different because the coordinates, the point of reference is different. And if I say that often enough, maybe I'll believe it. Oh well, what the hell. Even though this is physics, the calculations aren't that complicated. I can always go back and readjust it later. Okay, so difference X is 0. X equals I didn't actually need to spit like this, did I? Well, let's see. There should be some kind of sanity checking in there, but we do that at the end. Okay. just cut out this ifs now? Yeah, I think so. We'll just make this a plain old F. Now that we got consistent coordinate space, the positive and negative will carry right over. Let's see. Do we want a damping factor, or do we want the movement to transfer over exactly? I don't know. I think it's something we'll have to try. On the one hand, a damping factor is usually good to compensate for the exaggerated hand movements we need to do to get this to work. But on the other hand, I don't remember what the other hand was. Either way, we can copy this code as is for now. And we'll try it out and see how it works. First, we need to go through the rest of the physics code, though, because I don't think there is anything to actually use the Impulse X yet. So, next we have gravity. Clear out some of these unnecessary comments while I'm at it. Next is the collision handling, which isn't really relevant here. Lower cat? Minus 20? Oh, right, because that's Y momentum. So it should always be falling. The worst part of this is all the different directions and units, and positive means one thing in one place and another thing in another place. And, well, we got a lot of different reference spaces here. One thing's for sure, though. We're going to need a momentum X to go with momentum Y. So let's rename momentum to momentum Y. Hi there, Sandre. I'm doing physics plugin development for a VTuber avatar. What I'm doing specifically is using the hand tracking to give it the ability to throw a ball. I'll load it up and show you where we're at now. So, open up the hand tracking. As you can see, these ellipses move along with the hands, and hand tracking is jank. But yeah, we can catch the ball and throw it up in the air using our hands. So this is a step to make VTuber avatars more interactive. Nice little programming project for that. This isn't something that's supported by default, but I'm writing a plugin to make it happen. And I'm streaming myself writing that plugin. Right here on stream. That's what we're seeing now. So far, over the last couple of weeks, it only does vertical movement. So right now I'm adding the ability for horizontal movement. So, let's see. We don't need to lock momentum anymore right now. Instead, we need to look at the impulse X. Come to think of it, now that I've changed the way the coordinates work, it's now a bad thing to be damping out the difference in the... Yeah, currently we remove the sign from the tracking here, and the catch detection. But now that we've got the consistent coordinates, we don't want to remove the sign. That'll just give us a hidden extra catch zone. But since I'm thinking about something else right now, I'll just leave it to do and hopefully go back to that later. And so for now, let's see. We were looking at momentum, that's right. So momentum decay. For now, we can keep the momentum numbers from Y, I think. We'll definitely need a different momentum cap for X, but we can figure that out after we see it in action. First things first, let's see. We need momentum, that's what it is. We need momentum X. Because that's what keeps the ball, that's what keeps it moving for more than one frame. Okay, that should be a global, because that's something that needs to persist across frames. X equals 0. You found me funny? I'm glad to hear it. Thank you. I hope you enjoy the stream. Although this is just programming, so it's not always the most interesting. Different people have different feelings about that. But with me, it tends to be mostly chill, quiet streams, where we're just doing stuff. Okay, so now we should be able to handle the X impulse pretty much the same we handle the Y impulse. X equals impulse X plus momentum X. And then we'll handle the same one here. Momentum X equals momentum X times momentum decay. We'll probably need a different decay value, but we'll see. And let's handle what happens if it goes across the X boundary. Gotta remember to go back and set right boundary and left boundary, because right now we don't have them. And I won't remember, so let's do that right now. I'm not sure these are actually the right numbers. Well, that's easy enough to figure out. I'm just looking VTS. That should be close enough. Yep, 175. Oh, that's for the hands. What's the ball? Yep, 175, 175. Alright, so we got left boundary, we got right boundary. And if the ball crosses those boundaries, then and so it crosses the boundary, we'll just multiply it by -1 to reverse the sign. And that should give us a nice wraparound effect. Just like old video games. So go off one side and come back on the other side. That's the idea anyway. We'll see how that actually works in practice, but okay, anything else before we start testing that? Wow, that didn't take long at all to put together. That means debugging is going to be hell. Oh hey, the right hand is working. What's that? Not anymore. Something is wrong with the hitbox here. Well, I don't know why it works so much better with the left hand, but... Oh, there we go. So that worked. It looks like it's real touchy about doing that. Oh. I hate this. I'm not left-handed. Why does it have to be the right hand that's screwed up? This is hard. But it seems like it is generally working. Yeah, if anything, I'd say the main issue is that the momentum is decaying too fast on the X side. But still, that looks pretty nice. I don't know why the hell it's not getting caught in the right hand. That's so frustrating. I'll put in some log statements for it. So put one in for passing the RY. Next condition passed. Ball Y is greater than or equal to, and RY is something's probably wrong with the hitbox calculation, but oh, I think I get it. It's because this is an LSEF. So if both hands happen to be the similar height, the right hand gets skipped altogether because it's an else if. So if this is true and this is false, then the left hand won't catch it, but the right hand processing will be skipped. Let's test that theory. Get the hands at different heights. Yeah, there we go. And now get the hands at the same height. And yeah, it slips right through. Now we move the height. Such a simple problem all along. Well, we found it. All we gotta do is remove that else. That. And now without the right hand should work. This is so much easier. Within the confines of what we can do with the where are we getting accent balls? Did I forget to do something for the right hand? It's hard because it's also touchy. We're only checking one frame. Okay, the left hand doesn't have any problem with that. Did it move a bit? It's hard because this is on the edge of the tracking. What? Okay. I think that did something. We got working wraparound. So, do this. Can't tell if the X is working there. I guess a simple way to do that would be just be to log something. First though, that's... Oh yeah, another copy-paste problem. It's checking the right hand, it's checking the left hand instead of the right hand. So it wasn't working. Or if it did work, it was just because the left hand happened to move independently. It should work, right? Quick touch. Oh, that works though. It's sketchy enough that it'll be a real pain to do a demo vid for, but... Alright, dare I try to throw a ball from one hand to the other? Okay, we've got another contention here. Collision code. I'm pretty sure I know what happens. Yeah. because it's now evaluating them both independently, but it's not evaluating them at the same time. So right hand goes for second and decides caught equals false, but it's already been decided up here that caught equals true. Okay, so is there any need to decide to mark caught equals false here? Is there any need to run the collision handling at all if the ball is already caught? Caught is something that's carried over from the previous frame. So if it's already caught, we don't need to run the collision handling really because it's already caught. Problem is just then how we get it on caught. If it's thrown, then it gets marked on caught as part of that. If the hands just move but not enough to be thrown, then the ball is supposed to move with that. Simulate being carried. We only had that for the y-axis so far, which shouldn't amount to much, but let's try it for the left axis. The x-axis as well and see what happens. X, or y, L, yada yada yada. And so we'll encase the collision handling in another if block to ensure that it doesn't get run if it's already caught. And since we already know that coming in that caught must equal false, we don't need to set caught equals false. Of course, the downside of this is that we will no longer be able to drop the ball. It will be carried. The only way to get the ball out of the hand will be to throw it. But for the purposes of right now, I think that's fine. Yep, let's give it another shot. So can we throw it sideways? Oh, almost had it. Awfully slow, isn't it? Well, it looks like the catch code isn't working properly. Right, because no. Okay, so we're here. Right, because it's only being run in certain circumstances. Well, it makes it a whole lot easier to throw it. And look, we can throw it from one hand to the other. More or less. Yes! 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 Threw it from one hand to the other hand and caught it. We're like 90% of the way to juggling now. Fantastic. Well, I guess before I celebrate too hard, I'll try to solve the problem of the mysterious floating ball. I don't think it's really that complicated of a problem. I just need to figure out what runs when it comes to being caught. Let's see. Basically, the code to relocate the ball and keep it caught, to move it along with the hand, is only running when it moves slightly upwards, but not enough to throw. So the best thing to do would be to move it out. Ah. Interesting. Fun fact, I'm pretty sure this doesn't actually note down which hand is holding the ball. You could theoretically catch the ball with one hand and move it by jerking the other hand. Maybe? Not doing so bad. Okay, let's give it a try. I want to see if it works like I fear it does. Yep. It's janky, but with the right movement, we can throw it with just the left hand while holding it in the right hand. Maybe? I can't reproduce it. There we go. It's hard to reliably reproduce, but oh well. That's a distraction anyway. That's another thing we probably need to fix. One problem at a time. So we want to move this out to here. So move it outside the physics block so that basically if it's thrown, it'll be marked not caught. So if it's still caught after it gets through there, then it needs to be not caught. I mean, if it's still caught after it gets through the throw checks, then it needs to be carried. Okay. Do we want to track which hand is actually holding the ball? Well, I don't know if we want to explicitly say that info or just calculate it. Typically, I'm more inclined to calculate it. It suits my aesthetics as a programmer. I can make excuses, but that's basically what it boils down to. If data can be calculated, I prefer to calculate it rather than storing it. Unless, of course, there's performance considerations. Throw threshold. What's a throw threshold? It's pretty low. So combining this and this, it should only take a jump of 1.5 Live2D parameter to throw the ball. Which, the way I've rigged it, should be 15 pixels at base size. Which is maybe half the height of a hand, so it's actually kind of high. Maybe. I can turn it down. We're certainly not getting any issues with mistaken throws. We'll just switch it out like that for now. That should cut 0.5 off, or 5 pixels. And what was I doing? There was something I was going to do. Oh, right, the ball. Is the ball in the hand? So to calculate it, the natural thing would be, is the ball near the hand's parameters? So we'll do ball x minus hand x to get the difference between them. And use math.absolute to blow away the sign and compare just distance from 0. We have a y hitbox. Hitbox hand y. Oh, it's X this time. Okay, something's not right. I remembered it a second ago, but I've already forgotten. What's not right here? Let's see. Ref X and X. Right, we don't want the current frames values, because the current frame might be a throw. We want the previous frames values. So we don't want hand OX, we want physics state, where the previous frames values are stored. Alright, that's quite a mouthful of condition, so let's split it. And before we cram anything in there, let's copy it, because we'll need to do the same thing for the right hand. Just go ahead and convert the L's to R's now. Alright, so if last frame the ball was in the hitbox zones of the hand, then we check if the left hand is throwing it. How awkward. And on this side, we do essentially the same thing. Format it like this. I feel like splitting that in 2 lines is more confusion than it's worth. Like an animal with thorns. You want the scare to be right up front so you don't get confused. Let's comment this for our own future sanity. A small gift to future Ren. Alright, check if the ball was within the hand hitbox last frame. If so, this hand was holding it, so check the hand's movement to decide whether to throw. And the same thing there. Oh. Now, what else was I going to do? Was there something else I was going to do? Okay, this is what we were fixing. Right, we were fixing whether either hand could throw the caught ball, regardless of whether it was a hand holding the ball. So now we've implemented checking to see which hand is holding the ball. Alright, I think let's give it another test. Pull up the hand tracking. Let's switch it to hand tracking only so we can get better fidelity. Right. I don't think we solved the problem with the catch. We should have. I tried to solve it. So let's see what's going wrong. No threshold too big. The hitboxes might be too big. something is wrong. And it's the worst part of wrong. It's the worst part of something. It's the worst kind of something. It's a something where I don't know where the something is. Shoot. Why the hell did it get stuck up there? I can't get it down. I've got to kill the program just to get it down. Something is wrong there. Well, first things first. If the ball is moving upwards, we can't catch it. I'm just going to impose that rule right now. The ball has to be falling to be caught. Hopefully that'll do it. Oops, wrong side. It should be less than 0. Because you only want to catch if momentum is negative, which means that's going downwards. This feels good. Nice and easy. And we do a horizontal. Is it moving? Okay, we are getting it horizontal. You're just having trouble getting, we're having trouble getting a good throw, but it is moving. It's further away from the zipper. Okay, it's still getting stuck, but now it's making sure we can't throw it unless the hand is actually near it. Okay, I think lowering the throw threshold is a bad move. Okay, that should increase it to higher than it was before. And on top of that, if caught, the new ball position should be the hand position. And does anything change that? So if we're caught, these won't get run. If we're caught, impulse will be 0. Alright, so it should be moving along with the hands. Let's give it another shot. I wonder what the hell's going wrong there. Having trouble getting a good throw. Oh, there we go. That was a good one. Okay, so... So let's put in some logging. You all should get the general idea of how things are going with the hands by now, so hide that stuff for now. We'll go small window. And we'll give it another run. Let's try and carry them all. Well, that's interesting. So it is hitting this code block. So we'll log here and we'll log there to see change. Basically, we want to know if that value is making it all the way to the end. So, new ball position ball X. So we should log that value twice. Once when it's supposed to be set, then once we carry it. Okay. So that is being ignored. First case, are we even logging the right thing? First of all, we're mostly using the right hand here, so let's log the right hand. Oh, damn it. Again. If it's carried, it's always being set to the position of the left hand, regardless of which hand is actually carrying it. Once again, I've been sloppy with the copy pasting. Part of that was just me not thinking things through. So how are we going to do this? Alright, so this checks if the ball is currently caught. And this checks if it should be thrown. So we can pin an else here. And an else here. So right here is where we've determined which hand the ball is caught, but decided that we're not going to throw. So, minus RX, please. We'll leave that there. So this should at least help. It's not helping. Maybe I should have put a multiplier on the horizontal throws. Yeah, I think that'll make for much easier testing at least. So we'll just double it. Yeah, we'll start with double. And we'll break that out into a constant, so we don't have to set it in two places. And we'll put in some more line to see why it's still not working. And there we have it. Now we'll give it another shot. Okay, so we are setting new ball position, but it's getting blank somewhere. Because when it gets down to the bottom here, it's 0. So it gets set up here, but by the time it gets down here to be sent back to VTS, it's 0. Now, why is that happening? X. Now, since we're not caught, collision should be skipped. Ah, here we are. We're completely overwriting it here. So, in this case, we only overwrite if it's not 0 or if the ball is not caught. No, it's way simpler to just do it if the ball was caught. If the ball is caught, then we don't need to worry about any of this impulse stuff. So we'll set our momentums more comprehensively here as well. Honestly, this stuff shouldn't be run if the ball is caught too. Let's cram it in. Let's jam it in there. And if I'm right, this should be a significant improvement in the behavior. Uh-oh. Now it's not running at all. What did I do wrong? Oh. Right. This code should be running when the ball is not caught. Instead, I was having the physics code skipped when the ball was not caught, and I should be skipping it if it is caught. So... Alright, we're now carrying the ball. Looks rather nice, actually. Can we still throw it? Yes, we can. All right. Let's see how far we can reasonably throw it horizontally right now. Oh, that was a good one. The trick to a good throw seems to be to make it lose tracking for a second, so the hand snaps way over before it realizes it's back. Oh, otherwise, there's a limit in how much we can move one frame. Let's see how much a normal throw can travel. Luckily, we've got this debug info down at the bottom console telling us the ball's exact position, so... throw. Okay, we start at about 100. Okay, so that was about 50. Looks like we can generally manage about 30. 30 to 50 out of 175 total. Oh no, it's 175 each way, so the total width is 350. So I think we need to crank up the throw multiplier. So, throw multiplier. We're already multiplying it by 2, so the base number is probably about 15 to 25. Let's say 20. Let's make the multiplier 5, so 20 would become 100. Oop. It's an improvement. Whoa. Oh, it landed right in the other hand without me having to do a thing, so... Whoop. Cool. These numbers are feeling good. Still touchy though. This might just take practice. I don't really want to crank up the throw multiplier because we do get some good throws sometimes. Cool, cool. Maybe I'll make the throw modifier 6 or 7. Let's split the difference and say 6.5. Now let's crank her up and show the hands again, because I am liking where this is going. Catch the ball, pull it over to the side, throw. Oops. Throw. This is surprisingly tricky. It's a real dexterity workout. Juggling an invisible ball. Watching the screen to show where it is. Yeah, this works. This fucking works. Oops. Works even with the junk bunch. Yeah. Hello, where's my hand? Oop. Feeling really good about this. Yes. Oops. It got stuck. Which hand does I think it's off? Okay. Jank. Janky. Jank. Hello, where's my hand? There we go. This is feeling really nice. Okay, it's janky. It's jank. Whoa. Seems like I should probably put an upper cap on the X impulse. Woo. Because when that goes bad, it goes bad. Still, when it goes good, it's really nice. I'm feeling good about that. This is some good stuff. Man, I'm loving it. Whew. And another reason I've been breaking stuff out into constants, by the way, is because I think this is something that I can make available to other people. My goal is to have a JSON file where people can set the names of their stuff and indicate what object they want to be handled and a few other things, and then they can grab and throw whatever the heck they want. Obviously it's still going to be janky, but this is feeling really nice right now. I'm happy with it. Well, I can't expect people to rig their hands in a consistent coordinate space, so if I'm gonna make this public, I'm gonna have to revisit that. So leave another to-do here. Let's see. Other users won't rig their hands with positive in the same direction, so some param flipping in the program will likely be needed to support other users. I think that's close enough to coherent that I'll understand what it means later. Okay. And now I think it's time to start laying some pipe for the next step since I got the X values done so early. I honestly thought it'd take longer. So I don't think we'll have a deliverable for the next one yet this stream, but I think we can get started at least on adding support for multiple items. So we'll have to go through with all the places I've hard-coded a single wall and replace it with something that's a bit more flexible. And I think we'll also want to rename the ball parameters to item. Which, will we have to do that in both ends? Let's see, read the physics params. Yeah, we're reading Live2D params, so stuff on both ends will have to be named appropriately. So I guess this will go another pass through the rewritten to rename the parameters. But we'll leave that be for now and focus on the getting things consistent. So item count equals 1. Physics data. Okay, where's physics data come from? It's stuff we create. So ball will become an item. We'll change the actual Live2D parameters later, but I want to get this stuff all basically working. Item. Rename this item X, item Y. We'll look through for any more thing. Rename item position. And just look for any leftover references to ball. That's a good tune. That's a real banger. New item position. X item Y. Okay. We'll leave the stuff that's tied to the avatar itself alone for now. Visible, we'll leave as is. And there we have it. I guess we can go back in and do the re-rig. We've got time. It's only been 2 hours. That's not long for this at all. Once my projects get going, they really seem to blow through things. So we'll crack open the rigger again. Alright. Now the art meshes themselves don't need to be named anything in particular. You just need to change the parameter settings. X, open Y. Let's go a little further and make this item 1X, item 1X, item 1Y, item 1Y. Item is visible. Item is visible. That one's not really something that needs to be exposed to people, I think. And we'll go ahead and re-export, I guess, as usual. The hand rigging. Do I want to switch the hand rigging back? I can do that later, maybe off stream. For now, I'm just happy that it works and don't want to mess with it anymore. Item. Port. Yeah, all right, everything is going pretty good. How are you folks doing tonight? Is everyone having a good week? Everyone excited to see this potentially getting released to the public? That'll make some waves, I'm so sure. Now that we've renamed that, we can do another search. Item. Alright, and the only references to ball left are in comments. Which is fine for now. Alright, and the next step is multiple. So everything that's hard code for one item has to be able to check for it. Well, we're coding in how many items we have to look out for, so that's a plus. Now we just need to look at each step of the code and figure out how we can refactor it. So we start with process physics data, which goes to read physics params. So we're going to have lots of for loops. So, 4. Item count is 1. So we should put a sanity check in here that if item count is less than 1, then what says stop. Because if item count is less than 1, then all these for loops that are going to be based on item count are going to fail badly and probably messy. And so just to avoid that, we're going to decide right at the start. If item count is less than 1, you're not running this. No need for that anyway. So back to what we're doing. 6 data dot. Thanks. Actually, I got to think about how we're going to structure this. I mean, when we're working with arbitrary numbers like this, then the obvious thing to do would be arrays. But our actual items are going to be 1 indexed, while arrays are 0 indexed. So how are we going to handle that? Let's see. So maybe like this. Maybe it's because I'm sleepy, but I feel like there should be a smarter way to do this. I mean, I can make things more complicated by nesting objects. And, yeah, nesting objects seems like the simpler way to handle things. Not simpler, less mistake prone. Let's write this out just like sanity check my brain. So it would be something like this. So it's either that or having X and Y arrays. The physics data dot items 0 dot X. Honestly, both sound like overcomplicated pains in the ass. Well, we've got X's for everything. Should we make it something more something that's more wild, like have an X and a Y and have hand and hand. No, that offends my sense of decency. Say, I like my crap organized a certain way. Where do we actually handle physics data? Just there. What do we return? We return physics data. It gets sent in to be evaluated. Okay. So having an array of items seems like the right move there. This. Name this. So, yeah, this looks like probably the right way to do it. It's a way that feels most intuitive to me anyway. So that was just there to write it down as we reasoned it out, so. Okay, so for each item in the loop, we will push something to physics state. Now the question is the indexing. We're going to be starting our count for the parameters at 1, but arrays start at 0. We can, I believe, force it to index starting from 1 instead. But that's a really bad thing to do, generally. So the best thing to do would probably be to access just with +1s where we need them. Okay. So yeah, we'll just have to use a lot of +1s and get burned a bunch when we forget them, inevitably. 1 will go to 0. Okay, can we just put a number in here? Alright, let's think. So we got the param list, which is an array of elements. No, not an array, it's an object with each element having a name and yada yada yada. I think I got this, but let's pull up the API doc. Okay, so it is an array with objects inside. That's troublesome because that's basically the most annoying thing to deal with. You know, if you get objects, you can index by the object properties. If you got arrays, it's easy to cycle through. Having an array of objects. Well, I'm not one to talk considering I'm doing the same thing, but these are just number index. This param list isn't gonna be ever. Okay, anyway, change gears. So we need to have a special case for processing these. To make this X and Y capitalized just because I'm using capitals everywhere else. And those kinds of inconsistencies are just breed mistakes. Like a Pokemon daycare with a bunch of dittos in it. Alright, so we'll add a new case. And what shall we do for this case? I guess the thing to do would be to look for item in the name. There's something like starts with. There is. This doesn't feel right. I better double check the switch syntax. It always throws me off a little, much more than it should. Because really I just want to compare values to other values. I usually want to crunch some expressions, do some calculations, compare to the calculations. Okay, better. Actually, this seems like a good use for the default clause. Yeah, so if it doesn't meet any of these clauses, so I'll have to remember to remove these. So if it starts with item, then let's see. And dot name dot at 0, 1, 2, 3, 4. So it would be fourth character, 0 index. So the fifth character. So, if that one. That. Okay. We'll assign it to a variable. Num is less than item count. Less than or equal to. Because item count uses the indexing we'll have in the Live2D itself. So go item 1, item 2, item 3. And we're working in the Live2D context right here against the Live2D parameter, so you want to be equal to. So if item count is 4, then we'll have item 1, item 2, item 3, item 4, and so you want a less than equals. Now this is a tricky bit, and a bit we'll have to always remember. The array starts at a different number. Arrays are 0 index, so item 1 will be array item 0, item 2 will be array item 1. Item 3 will be array item 2. And so on. It's touchy, but I expect non-programmers to be using this, so we want to go with a user-friendly solution for them and handle all the complexity internally. That's the user interface in a nutshell for you. Is this something reserved? I got a bad feeling about how that's showing up as blue. Why is that showing up as blue? Well, it's easy enough to change later. Rename symbol is powerful. If it bites us in the ass, we can deal with it then. Yeah, that's what it is. The capital letter, the first item in a variable, the first character, it shouldn't be 0. Let's make it value X. It's longer and kind of inconvenient, but it reduces confusion. And that is worth one hell of a lot. Okay, so item 2 would come into here, and then go into array slot 1, and then assign to X or Y. This contains case sensitive. Hopefully I don't need to care. Comment those for now. And now we've made it back to returning the physics data. Now we evaluate the physics data. Which means coming up with new solutions for this. That stuff down. And let's see. Probably we want an array. How are we going to handle the array exactly? First things first, physics data dot item x dot x. Just writing that down to get it into my head since it's still new and fresh, so I don't quite remember it yet. Okay, so Thinking. Here's a good idea. Why don't we handle the number conversions when we're parsing this crap in the first place? That saves us the trouble of having to tear that all apart again just to crunch it. So, number. And now that's all taken care of from the very start. Which means we don't have to handle it here. Instead, we can just say that items equals physics data dot items. Items, very important. So we've saved ourselves a unnecessary 40 there. We'll comment that for now. New item position. We'll have to deal with that, but oh my. Come to think of it, the impulses and momentum and everything else will all need to be ball by ball. We're going to have arrays everywhere. You get an array. You get an array. Everybody gets arrays. My god, I didn't think this through at all. The momentum's X and Y get to be arrays. This is going to be more of an undertaking than I thought. Alright, so let's see. The constants should all be able to stay as they are. For now, we're going to assume that all the items being thrown are going to have the same physics behavior. We can come back and revisit that assumption later. But for now, I'm quite happy to keep it that way. Alright, so where are we? Let's see. New item position. Let's see. I'm not planning to implement collisions between items. That would just be a big mess. So I feel like the best way to do this would... What is this? Why is this here? The best way to do this would probably just be run physics separately for every ball. That way you only have to extract the value from the array once and feed it back in once. I can run physics one item at a time. That does have the disadvantage of it not running parallel, but it's not as if I'm planning to implement parallelism right now anyway. I certainly could, but that stinks of premature optimization. So far, we're not running into any performance issues, and with any luck, it should stay that way. So, alright. Come on, Snippet Maker. Give us a big fat for loop. Alright. Data, dot, bins. Oh. I have to dump everything in that for you. Or damn near everything anyway. What a mess. What a goddamn mess. And at some point I'm going to have to think about how to actually return those values, get them back out of here. So, is everything... Okay, everything lines up. No, everything does not. Does it? I'm confused. Okay, here's our 4. So everything should be right of this line. Alright, we're good on this front. Now, items should be an object with value X and value Y. Y. We'll come back and revisit that. Once momentum equals okay. So we should initialize momentum at the start too. Okay. 4. X dot push 0. Then Y dot push 0. Don't even need to do that. I can probably just initialize it directly. Or no, it would be empty in that case, wouldn't it? Yeah, I don't need to do that just yet. Oh no, it's good practice to have known values in there. If I initialize just from the value, then we're going to have undefines in there, and that'll just make a big mess of everything. Alright, so we initialize momentum. Now where were we? Okay. Is quant scope? I better check that. Okay, they're block scoped. So this one won't overwrite the global one because it's block scoped. So this momentum X will only exist in here. Good, that's exactly the kind of thing that block scoping is useful for. Being able to just run roughshoot over your values like that. Now go through the long process of replacing values. Long and error prone. New item position we'll leave to figure out for later. Right now we're getting the base values here. So we're replacing all values of item 1y with item.valuey. Item.x, item.valuex. Nice and smooth. Okay, now we gotta figure out new item position. I think we can probably do that in array the same way we did the other ones. Yeah, I think that would make sense. So, once again, position equals an array. And we'll change these to value x and the value y. And then at the end, we'll push this to this list here. First, we'll go through and check that everything updated properly, because as somebody who is a computer himself, I know better than to trust computers. position, yada yada yada. Looks good, looks good. Looks good. And good. Put in the right place, we sure did. And now we return the list. And so the list comes out here. And goes into update item position. All right. And now here's where we create the actual list of parameters to go back to VTubeStudio. Feeding in data. Parameter values. Now this shouldn't have to change much at all. We just toss up our nice friendly array. Set the values the way I like them. Right. For each value. That item goes to position list. X item dot value Y. Plus 1, because once again we've got to convert from array indexing of 0 to Live2D indexing of 1. And we do the same thing here. Comment out the old stuff. And from there, I think nothing else changes because we've just made a miscellaneous pile of parameters to go back to VTubeStudio. We do, however, need to make sure we have the right parameters in the first place. Which is, again, a simple matter. We just do the array, same as we've always done. And here it's pretty much exactly the same as we did up here. In fact, I think we can just copy paste that. And there we have it, I think. I'm scared to test it. I can't leave it as it is without testing it. It's such a mess. Well, Power this will get us nowhere. Let's turn it on. Item num is not defined. Yeah, I scrambled. I messed up at some point. Started putting item num when it should be item app. Wait. I can't just do a find and replace because sometimes it's supposed to be item. No. So I gotta look at each one individually. At least it's pretty easy to tell which is which should be which. Alright, and let's give another paw. So, X. But not accessed before initialization. Oh, well, okay. It shouldn't be happening. Okay. Let's fire up the debugger and see where this error is coming from. Okay, so I guess there was a problem with the shadowing. Oh, that's easy enough to fix. Momentum list. Surprised we had that issue, but whatever. Oh, right, that's stupid. Momentum can't be a constant because it changes. Good thing I'm still running in debug mode. Well, we got good news and bad news. The good news is no more errors. The bad news is the ball is not moving. Oh, right. That would be my fault. Since we changed the parameters, we have to change the parameters in VTubeStudio. For whatever reason, this parameter assignment is the one thing that can't be done programmatically. Now, why are we having problems? Alright, what's going on? I guess the obvious question is, what are we sending back to VTubeStudio? It's pretty clear that something ain't going right, but date, item, position. Alright, now what's request look like? Well, we're not sending useful values. Why not? Where is the value getting lost? What does new item position this look like? 0 and 10. So something somewhere is not getting calculated properly. So impulse Y is correct. It's not caught, so go in, set our impulses. X, impulse Y. Okay, I see. We're not getting the right values in to begin with. Okay, so physics data items. Alright, the physics data isn't being set. Where does the physics data get set? Physics state. Where do we compare physics? Ah, yeah. Physics state. Well, actually, physics state should be fine. Let's look at what we save here. Okay, we'll go back to the very hard bit. Ah, that's right. I exported the new avatar, but I didn't actually put it in the VTubeStudio. So I'm using the wrong avatar. And it's not finding the values because the values aren't there. Let's pop off to a side screen for a moment so I can switch up my... And we're back. Oh, but with an additional problem. Since we changed the name of the ball parameter, we've got to modify the expression file. Is it item visible or items visible? I guess we'll find out. Oh, I guess I messed up a bit. Let's speak into the viewer real quick and check our parameters. I guess I could check that in VTubeStudio, but this is faster anyway. Items visible. Good to know, good to know. Okay, I'll write that so it doesn't get too far out of sync. And now let's pop over again. This time we'll be a cat for a minute. Yeah. I'm a cat. Yeah. Yeah. Anyway. Alright, ball shows up again. Hands show up. Hide the clock. Fix the parameters. So now item 1y should go to item 1y. And the same for x. Again, this is a piece that absolutely has to be done manually. The API doesn't allow it to be done, as far as I'm aware. Alright, now that we've gone down that side trip, let's give it another shot. Element.name.contains is not a function. Oh, this is what I get when I try to do string methods from memory. Let's see, check out MDN. Okay, looks like it should be includes. Alright. We're back to working. Somewhat. Ball is noticeably slower now. And catching isn't working. I should have stopped earlier when I had the single ball case working and made some demo videos. Sure would have been nice to set this up on Git. Ah well. Let's see. debugging. I don't think we're in debug mode. Let's put it in debug mode. Stuff that I was going to say no is working, but it's more like we think it's working. Alright, now we've got debug set up, so when we try to catch, should just get some breakpoints. Make sure we're in a catching position. Because they're getting pulled in as block scoped, but it's just being pulled in by value, not by reference, so the momentum values aren't getting read back out to the global state. So down at the end here, Y. So hopefully that should help matters. Oh, that was it. And with that, we're back in action. Nice. Here, I was getting ready to start thinking about rolling back. Blended. Still janky on the wraparound, but whatever. This is great. I'm quite pleased with how it's going. And we even got the multiple ball support rigged in, at least in theory. That was something I wasn't expecting to get to till next week. So I think for tonight that's a good place to leave things off. Next Friday at the same time, 7 p.m. Eastern, we'll be continuing with this project. There's not much left to do. Probably we'll be rigging in multiple balls, rigging in actual multiple balls or multiple other items. We'll try and externalize some of these values to JSON files so that they can be used by other people and set custom for each environment. And maybe rig in some fancy special effects or something like that. And tomorrow night, I will be playing video games again. Saturday night, 8 p.m. Eastern. Probably Factory Town again. I had a good time with that, and there's still plenty left to do there. Let's look at our options today. Let's see, there's K-Pan, there's Bell, there's Cena, there's a fair amount of people online. I guess that's what happens when I stop streaming at a reasonable time. But we get a fair choice of people to raid. I think this time we'll go ahead and raid my pal Arvar Grenadier, who is playing Pathfinder Kingmaker. I don't really get what's going on there, but we'll do it anyway. Thank you, everyone, and have a good night. I hope to see you tomorrow and see you again next weekend as well. I hope everyone's had a good Thanksgiving week, and I hope everyone has a good night and a good weekend. Thank you for coming, and have a good night.